Some technologies don't vanish when their job is done, they get repurposed, preserved, or pushed into places nobody expected. In this compilation, we follow the machines and systems that quietly changed how people built, moved, filmed, and played. A fusion machine that was meant to leave Canada ended up behind museum glass instead. The Tokamak de Varennes was built as a tokamak, a machine that uses magnetic fields to hold hot plasma in place. It had a planned next life outside Canada, but the attempted sail to Iran did not go through. Without that destination, the machine was preserved at the Canada Science and Technology Museum as a display piece. A device built for plasma research became a physical artifact, with coils, panels, and the quiet museum floor around it. Two planes can land almost side by side on runways only 750 feet apart. That works because the landing is not improvised. Controllers and pilots use a simultaneous approach procedure. Each aircraft follows a precision approach path, a tightly defined lane in the sky. Separation rules keep the two runways coordinated. With those paths locked in, airports can land more traffic on the same footprint. No extra runway field is needed. So a narrow strip of pavement becomes a managed system of approach, spacing, and touchdown. On the ground, that means another landing slot and another waiting aircraft. Seattle is planning a rail line to ride across Lake Washington on a floating bridge. That is a rare place for train tracks. Link Light Rail already runs across the Seattle area, with Sound Transit managing lines to Seattle, Bellevue, and Redmond. Most rail systems prefer rigid support, not water. The challenge is the bridge itself. A floating bridge moves slightly, so the track has to stay aligned while the water shifts underneath. If the crossing works, it links the east side to the rest of the network through Bellevue and Redmond. A commute becomes a bridge problem, not just a train ride. That is Seattle's geography in one transit project: water, rail, and a bridge that has to carry both. The answer sits in the alignment over Lake Washington. The biggest wind-propelled cargo ship is not a relic. Neolinear Origin is hauling freight with sails right now. Neolinear Origin is a sail-powered roll-on, roll-off ship. Vehicles and cargo drive on and off through a working freight deck. In 2025, it began service on a transatlantic route. French company Neoline built it to cut carbon emissions in merchant shipping. The key is matching the route to the ship. Steady wind across the Atlantic can move a cargo ship without relying only on engines. That makes a very old idea useful in modern logistics. A cargo ship, a transatlantic route, and a clean line of sails now share one deck. Jenny of the Prairie was built for girls, not as an afterthought. In early computer games, that was unusual. The game was an adventure game in the early personal computer market. Most titles still aimed at a general buyer, not a specific player group. Jenny of the Prairie stood out because its audience was chosen on purpose. That makes it one of the first computer games developed specifically for girls. That choice shows software makers were already targeting audiences by design. A game could be shaped around who they expected to play it. So the title becomes a clue about the computer era's market thinking. On the shelf, a simple adventure game points toward a specific player. A camera built for still photos showed up on movie and TV sets. Canon EOS bodies were used on House, Dexter, and Iron Man 2. That mattered because sets already mixed cameras, lights, and monitors. If a camera could fit the workflow, it could earn a place beside larger gear. The crossover happened when filmmakers tried the EOS system for certain shots. They used it for portions of House, Dexter, and Iron Man 2. That meant one camera body could move from photography into motion production. For some shots, the EOS line was useful enough to join the set. So a familiar camera shape became part of the movie pipeline. On the cart, the EOS body sat beside lenses, batteries, and a monitor. An engineer saw her own mixing console behind museum glass. Annalija Soklik had built it herself. Most audio equipment is meant for daily work, then upgrades, repairs, or scrap. This one stayed intact long enough to cross that line. The key shift is simple. Preserved engineering becomes heritage. The console was no longer judged only by sound, but by its design and craft. That display gives people a place to study audio hardware as a physical object. Buttons, faders, and wiring become part of a public record. For Soklik, a control panel she once built for sound now sat as a historical object. The machine rested quiet in the museum case. One engineer studied the aerodynamics of horse-drawn gliders, sailboats, and throwing knives. That mix sounds impossible at first. The objects do not share a job, but they all move through air. Each one meets airflow in a different shape and speed. Aerodynamics is the study of how shape and airflow create drag, lift, and stability. Lawrence J. Lesh could use that same logic on all three. Once you see drag and lift as shared problems, the category matters less than the flow. A boat, a glider, and a knife all become shape problems. That is why one set of aerodynamic ideas could travel from horse-drawn gliders to sailboats and throwing knives. The common language was airflow, shape, and a moving edge. If you enjoyed these hidden engineering turns, subscribe for more factual stories behind the objects we use, and tell us which one surprised you most.